This video explores how to evaluate LLM-based agents, systems that use large language models to reason, act, and interact. For both human and AI systems, real-world performance often relies on not just intelligence, but also on the ability to reflect and improve. While we will focus on evaluating agents, these insights might help you reflect on your own decision-making process and how you might increase your real-world performance. This video will make use of third-party LLMs and take their level of performance as a given. We will not do any fine-tuning, so we aren't evaluating the LLM itself. What we will do instead is evaluate the LLM's performance within the context of our setup. As the LLM improves, our system's performance should improve as well, but till then, we just do the best that we can with the model that's available. Before we can evaluate something, we must first understand it. So, what does an agent setup involve? Creating an agent can involve a mixture of software development and human reasoning. Software development in relation to agents involves things like connecting to databases to fetch context for models, connecting to APIs to initiate actions, and of course converting all our logic into code. Converting logic into code involves taking the ideas on how the agent should be set up and creating some code base that reflects this. In terms of human reasoning and its role in agent setup, it is important to ensure that the way in which a process is set up makes logical sense. Given the available context and the task, is there a clear logical way of getting from the context to the desired result? In philosophy, which can help us understand reasoning tasks, we would ask whether the premises logically infer the conclusion, or conversely, does the conclusion logically follow from the premises? For example, if we have two statements, this water is cold and I don't like cold water, and a question, will I like this water? It logically follows that no, I won't like this water. We can use LLMs to fill in some logic, but only what is considered common knowledge. While LLM improvements could expand a LLM's common knowledge, a lot of information is unique to the context. Back to the previous example, the statement, this water is cold, is unique context because another body of water might be warm. So, no matter how good a LLM becomes and how much common knowledge it has, if it is missing important context, it won't make good suggestions. This is in some way similar to a smart person knowing a lot but still failing because they aren't willing to listen and learn about the unique circumstances of a situation. When setting up an agent, understanding the current best practices can also be useful. At a high level, this might involve understanding that we have things like tool calling, memory management, and sub-agents that we could integrate into our setup. Given the rapidly changing environment, in addition to learning, a focus could be placed on experimenting, continuous improvements, and observing what others are doing. The same applies beyond technology. No amount of reading about swimming can replace the act of getting into the water. In business and in life, learning by doing transforms abstract knowledge into real competence and results. Additionally, practice doesn't need to replace learning. Instead, it can complement it. If you apply only limited knowledge, you may fail for many reasons, but the act of failing shows you what you need to work on. Failing can be a tool that you can use to fine-tune your focus and ultimately lead to much faster progress. For our application, we are going to build a single conversational agent and we will collect data to evaluate its performance. Initially, we might just manually test the agent a few times with different prompts. However, in the long run, more complex evaluations might be worth the development effort. Our agent will be given a tool that it can use to get context in order to answer a user prompt. To evaluate this agent's performance, we will use a LLM as a judge. This eval or evaluation LLM will be given the original query, all context fetched, and the final answer. It will not be given the main agent's reasoning to avoid it following the same thought process. Think of this like a teacher grading a student's essay. The teacher sees the question, the sources the student used, and the final answer, but not the student's rough notes. That way, the teacher can spot gaps, mistakes, or unclear reasoning without being influenced by the student's thought process. The eval LLM assigns labels like insufficient context, hallucinations found, or vague answer. Tallying up these labels could reveal patterns. Maybe the agent keeps missing key data, or its reasoning is too simplistic. These insights can guide improvements. To conclude, if the goal is to perform in the real world, then evaluation is the bridge between clever strategy and useful results. In the context of agents, you could begin with just a single agent, measure the obvious failures, fix those, and repeat. You may be surprised at how quickly disciplined improvements compound into meaningful outcomes.